In this series on comparing groups on a quantitative response variable, we have been looking at multiple comparison procedures, and we're ready to look at our final one, and that is Scheffe's procedure. I'll remind you that Scheffe is a bit special in that you can use it for exploratory analysis. You can actually look at the means and make decisions on which combination of means you might want to compare to what other combinations, or which particular pairs you're going to look at. You can try to hunt for the biggest difference and create confidence intervals for those if you wish to do so. Scheffe assumes that you have already rejected the omnibus null hypothesis. Otherwise, we do not move forward with the Scheffe confidence interval procedure. I also mentioned in a previous video that all of these procedures we're looking at can be done within base R without doing anything but by hand except for one, and this is the one, but it's not too bad, as you will see. In fact, we've probably already up here did some of the work that we needed to do by hand, and indeed we have. When we were learning about contrast and what they meant, we created this little code chunk here. I'm going to go ahead and copy it down below so that we can reuse that as we look at Scheffe. So this would tell us the difference between each pairs of means. Now remember that Scheffe can be used for any number of pairs, not all pairwise like Tukey, but you could use it for one pair, but it can also be used for complex. So if, for instance, we wanted to combine individualist and hierarchicalist and compare it against the egalitarian, we could use Scheffe for that. You can do anything you want really with Scheffe, and you can make as many of them as you want. I'm going to keep it simple and stick with this paired situation just for teaching purposes. We again assume that there's homogeneity of variance. Why do we assume that? Well, the other piece we did up here before is when I was teaching about the contrast, is that we took the variance of the contrast and notice that we created these variances of contrast using a mean square error. That is, we assumed the same error within all our conditions. So here I was comparing the first two conditions. Here I was comparing the first and third. So this is, let's see, individualist against hierarchicalist. This one was individualist against egalitarian. And this one was hierarchicalist. Contrast it with egalitarian, and we created the variance of those contrasts. And I also went ahead and looked at the standard error for each of those particular contrasts. Let me actually formalize that standard error by going ahead and storing it so that we have the standard error of contrast. Okay, and I'll go ahead and print it out again. So you'll see I haven't changed anything. I just stored it. Okay, there it is. All right, so now for Scheffe, what we're going to do is we're going to create the margin of error by hand. Well, the margin of error is just the critical value times the standard error. Well, look at this. We've already created the standard error for each of those three contrasts right here. And we have the contrast right here. So let's go ahead and enter in another code chunk here. And what I'm going to do in this code chunk is I'm going to create the critical value. Well, if you go back and look at the ANOVA table, right here, the degrees of freedom we need for the F are 2 and 222. And so here is the formula for getting the critical value for Scheffe. And unlike Bonferroni, doesn't matter the number of comparisons, it's only one critical value, so we only have to calculate this once no matter how many comparisons we're doing. Scheffe is, first of all, here's the F from the F distribution with 2 and 222, and we got a critical value at 0.95. You don't have to adjust it. The adjustment is done automatically in the entire formula. And that includes taking this critical value from the omnibus F, multiplying it by the numerator degrees of freedom, that's that 2, and then taking the square root. And so if I do this, that will give me a critical value. I can see over here in my environment window, it's about 2.46. So there's the critical value. Let me now use that critical value to calculate some contrast. Let's do contrast 1. Okay, so up here, I created a contrast 1. So I'm going to have contrast 1. And then what I'm going to do is plus and minus. So I'm going to do plus, and I'm going to use a little trick here. The little trick is this. What it's going to do is it's going to add both 1 and minus 1 times my margin of error. And what is the margin of error? Margin of error is critical value times the standard error. Well, the standard error that I want is this first one. So I could type it in by hand, or I could just say standard error of contrast, and I'm doing the first one. So this is the first contrast right here. Oop, I didn't put contrast 1. There we go. First contrast right here. And I'm going to plus and minus it by margin of error. Critical value, which I just calculated here for Scheffe, times the standard error, which I saved here, and the first one is the one I'm doing. So let's look at that. And there's my confidence interval. My confidence interval goes from 13 to minus 9, or the other way around, minus 9 to 13. Actually, let me switch this from minus 1 to positive 1. That would make more sense. Don't know why I did it that way. There we go. Minus 9 to 13. That's my confidence interval. And that is for comparing individualist to hierarchicalist. If I want to compare individualist to egalitarian, that was the second contrast. Let's go ahead and do that. And so for contrast 2, we have, again, same thing. And the only thing that's different is I'm going to use the second contrast standard error. And I did something wrong. I misspelled contrast. There it is. 2.5 to 25.5. Back when we did Tukey, it was the individualist against the egalitarian was 14 to 25 or 20, yeah, no, sorry, that's the difference is the 14. It was 3 to 25.1. 3 to 25.1, and here I got 2.5 to 25.6. Notice this was a little bit wider than when I did Tukey. When I did the individualist against egalitarian with Bonferroni, I had 1.6 to 26.5. If I compare it down here, this one is actually a little narrower, and you might say, well, wait a minute, why is this one here wider than Scheffe when usually Scheffe is wider than Bonferroni when you only have 3 contrasts? Remember that this one, we had differences in the standard error. And that's why that rule of thumb is just a rough rule of thumb. It doesn't always work. This would work. Bonferroni would be narrower if we had used or it had a common standard error, or if I had forced this to use a common standard error, but I'm not going to do that because one of the benefits is not to assume a common standard error. But all 3 of these, as you see, when I look at all 3 of these, they're all pretty close. 2.5 to 25.5, 1.6 to 26.4, and then about 3.0 to 25.1. So Tukey was the narrowest, but all of them are pretty close. It really is just playing around the edges with each of them. If I had many, many more pairs, many, many more confidence intervals, then that's when we'd start to see the differences. Because let's say I had 5 different groups. Well, 5 different groups, you can have 10 pairs. And if you decide with Bonferroni, I'm only going to look at 3 of those, that's going to be a lot narrower than Tukey. And if you have 10 groups and are doing Scheffe, well, what happens with the critical value is this number becomes quite a bit larger. Remember, that's the degrees of freedom for the numerator, which is the number of groups minus 1. So that becomes a 9 instead of a 2. And this becomes a much larger critical value, and you get much wider. So the lesson here is if you have a lot of groups you're looking at, you probably want to think about real specific questions of interest and narrow it down to 2, 3, 4 confidence intervals rather than looking at all your different possibilities. Okay, that's it for the multiple comparison procedures. I've got a report challenge to do, and I will take that on in the next video.